Hey everyone, welcome to week 10. This week we have 2 assignments and a discussion post. So assignment 14 and 15, and then a discussion post. The discussion, you might find it to be a problem that's similar to the problems that you're working on in assignment 15, but offers a little bit different of an angle. So enjoy that little video. And then let's look at 14 to start things off. So we're really getting into some probability. So the first thing you'll do is a little experiment with a die. So if you don't have a die, there's a link right here that you can use to roll a die, but we're only worried about 6-sided die for this problem, or dice. And so if you're not familiar with dice, 6-sided die, fair die, is a cube that has these on the 6 sides, right? 1, 2, 3, 4, 5, and 6. And you roll it, and then the side that ends up face up is the one that you're going to record. Okay, so you're going to have to roll a die. If you have one, you can use your own. If not, you can go to that website. And what you're going to do with this problem is just roll it 30 times. So you can use that tally box if you want to, right? So let's say you roll the die and it comes up face up 1, then you can just put a tally there. And then it came up 3, and then it came up 2, and it came up 5, came up 2 again, and then, I mean, 3 again, whatever. 1, you're just going to kind of keep track as you go, right? Something like that you'll probably end up with, okay? And then once you have it 30 times, just tally up, how many for the total, and you go down, right? Before you do it, you might want to think about what you would expect to see for your totals. Okay, so think about that before you do the experiment, and then you can record it. Okay, and then you're going to answer this question: do the results fit the expectations? So think about your expectations before you roll it, do the experiment, and then does your experiment fit your expectations here? Just to give a little explanation about that. And then think about number 3. Instead of rolling the die only 30 times, what if you did it 3,000? Don't actually do that. But think about what if you did, what would you expect to see? Meaning, what kind of totals would you expect to see for each of the 6 possible outcomes? Okay. And then we'll get into some basic terminology. So let me just go through some of this real quick. We're looking at probability experiments. So that will be, this is an example of it, an action or a trial through which specific results are obtained, right? So I put an example there in italics. The experiment that we just did consists of rolling a fair 6-sided die, okay? So the term outcome means the result of a single trial, right? So we roll the die and it is a 3. So the outcome is that it was a 3. Sample space, when we use that term, that's the set of all possible outcomes, right? So in this experiment, the sample space, as you can see there, and you notice the little notation. So it's just, it has that little squiggly brackets and then lists all the possible outcomes. That's the sample space. So there are 6 possible outcomes in our sample space, and we can list them separated by commas between the brackets. Okay, so that's important when we get to calculating probabilities. And then an event is 1 or more outcomes, which is a subset of the sample space. A good example of that, and usually the event comes with the probability question. So the question here is, what is the probability of the event rolling an even number occurring, right? So it's the probability that you roll it and you get an even number. The event there would be you get an even number. Finally, we get a formula, right? So the formula, which is theoretical probability, and we've got some notation here. You'll see this little P parenthesis E, that just is math for the probability of event E occurring, okay? So the probability that it occurs is a fraction. The top number is the total number of outcomes that match event E. And the bottom number is the total number of outcomes in the sample space, or just the total number of outcomes possible, right? And so finally, the range of probabilities Probability is always between 0 and 1. Could be 0, could be 1, or it's a number in between, right? You'll never have a probability greater than 1, because the reason for that is that top number is always less than or equal to the bottom number, right? So it's always going to be a fraction smaller than, maybe equal to 1 if it's 100% likely. Okay, and so probabilities can be written in three ways. You can do a fraction, or convert that to a decimal, or convert that to a percent. So any of those are fine. When you do these problems, you can give fraction, decimals, or percents. So you'll do a little example. They're pretty simple questions, just to get used to answering questions about probability. So in this example, number 4, again, our low probability experiment, what's the probability of rolling a 3? So I would recommend using the notation, right? So you're going to write this, and then you can just write the fraction. Probability of rolling a 3. Remember what you're doing there. The bottom number is the total number of outcomes in the sample space, or the total number of possible outcomes when you roll that die. And the top number is the total number of outcomes in the event rolling a 3. How many ways can you roll a 3? Okay, so you're going to put that fraction there. You can leave it as a fraction in reduced form, or decimal, or percent. Any of those three are fine. Okay, and then there's rolling an even number. Same kind of thing, right? You can just do probability of even. You can even put a word in the parentheses, right? And then fraction, total number of outcomes in the sample space. How many ways can you get an even number, right? And then same for C, rolling a 5 or a 6. Okay, so that's just practicing some basic probability and using the notation. Another example, this one's a little more complicated, right? You're rolling a 6-sided die and you're tossing a coin, right, which has 2 outcomes, heads or tails, right? So in this one, you're going to first list the sample space. So when you do that, you're just going to start with your squiggly bracket and then list all possible outcomes. Remember, you're doing the die and the coin at the same time. So an outcome, in this example I gave, you got a heads on the coin and 1 on the die. So I would list that as H1, comma, right? And then think of all possible outcomes, right? Matching something on all of them that are different, right? So you could do, the next one maybe tail 1, right? And then just keep on going, see how many you can get, okay? Try to get them all. And then once you have the sample space, you can answer some probability questions, right? So those, probability of 3 and tail, or what's the probability of T3 in this case, right? The bottom number is the total number of outcomes in the sample space, which is basically how many things you listed up here, right? And then the top number is how many ways can you get that event, okay? And then it's similar for part C. Okay, finally, we're going to link this back to that Monty Hall problem. Right, this one is different because it has 10 doors. But let me just take you back to the one with 3 doors and talk about that real quick. So let's just think about probability with the Monty Hall problem with the 3 doors, and how probability can help you to decide to stay or switch. So you probably already have a strategy for that based on your experiment, but now we can link it to some theoretical probability. So we have door number 1, 2, and 3. And let's say we just know where the car is. So the car is in door number 1, and then you have goat on door 2 and door 3. Okay. And let's think about some probabilities here. So let's first assume that we are going to stay no matter what, right? If we stay, what's the probability of a winning? Right. Well, probability, what is the total number of outcomes in the sample space? If we stay, we have 3 choices, door 1, door 2, or door 3. So there would be 3 choices or 3 outcomes in the sample space. Now, of those 3, how many ways can we obtain the event, which means we win the game? So the only way, if we're staying, to win the game is to choose door number 1. So that's one choice, not because it's door one, but because there's just one door that has a car, right? So the probability of winning if we stay is 1 out of 3. Okay, now how about if we switch? What's the probability of winning, right? We still have 3 choices, right? So I still know the bottom number is 3. But how do we win if we switch? Well, let's look at each case. If I choose door number 1, I've chosen the car, but then I'm going to switch to either door 2 or door 3, depending on which one is shown to me. So if I choose door number 1, I lose. What if I choose door 2? If I choose door number 2, remember the rule for the host is that they show you a door with the goat. So if I choose door 2, he's gonna show me door 3, and then my only option is to switch to door 1, and I win. So if I choose door 2, I win. So if I choose door 1, I lose. If I choose door 2, I win. What if I choose door 3? If I choose door 3, he's going to show me door 2, and then I switch to door 1, and then I won again. So if I chose door 3, I won. Okay. In summary, then, there are 2 ways to win out of 3. Right? So this shows me that switching is better. I have a 2/3 chance of winning if I switch, a 1/3 chance of winning if I stay. Therefore, I would switch. Okay. See if you can use that reasoning to do that problem now with 10 doors instead of 3, but it's similar. Okay. And that's the end of assignment 14. Let's go to assignment 15, which is on some new games, dice games. Okay. So this one, you're going to have some non-standard dice. So here we have one where there are 3 dice. So your green one, all of the sides have 3s. Okay. Your blue die, you have 2 sides with 0s and 4 sides with 4. And then the yellow, you have 4 sides with 2s and 2 with 6s. Okay. And then you're going to answer the questions based on rolling those non-standard dice. So that should be interesting. Okay. So again, when you're doing these probability questions, always think of fractions, right? What's the probability that you roll a 2? Think about the total number of possible outcomes when you roll that yellow die, and how many ways can you get a 2, right? And then again, you can write these as reduced fractions, decimals, or percents. Okay. And then you start doing some other things like rolling 2 dice together and adding the numbers and then filling out a little table. So what I'm going to do, and then we'll get to that in a minute, answer some questions about that table that you made. And then you're going to go heads up against another die and decide who is going to win. And then you go through that. Okay, so I think what would help is if I go through an example with some different numbers that would help you with these problems if you need it. Okay, so let's just do a new note. And let's say I have 2 dice. The red one has numbers 1, 1, 1, 5, 5, and 5. Okay, and then I have a blue die that has 0, 0, 3, 3, 6, 6. Okay, these are my 2 dice. And first off, what I want to answer is, if I roll these 2 dice, what's the probability that they sum to 8? Probability of sum to 8. Right? How could I figure that out? Right? I know there are some ways I can get sum to 8. Not too many, right? I just can see that I would need to get a 5 on the red and a 3 on the blue, right? But how often is that going to happen when I roll this dice in the long run? A good way to tackle these problems to figure that out is figure out all of the values in the sample space, or figure out all possible outcomes if you roll the blue and the red die. And that's why we're going to make a table, because there are so many possibilities, right? So I can make this little table, and I'm going to put the red values up top, 1, 1, 1, 5, 5, 5, all of the sides. And then for the blue, we'll put it over here, 0, 0, 3, 3, 6, 6. Okay. And what you end up making is, it kind of looks like an addition table almost from elementary school, really. Okay. And then now I can write down all possibilities, right? So if I get a 0, if I do this side on the blue and this side on the red, that would sum to 1, right? So would that, and so would that. This one would sum to 5, right? 0 plus 5 is 5, 5, 5, right? And then these would be the same. Okay, now if I add 3 each time, 3 plus 1, these will be 4s. 3 plus 5s will be 8s, right? And then this is going to be the same because of the 3. And then finally, I got the 6s. So 6 plus 1, 7. 6 plus 5, 11. And then 7, 7, 11, 11, 11. Okay, what we've just generated is all possible outcomes. This is a list of the sample space, right? There are 6 by 6 or 36 possible outcomes when I roll these two dice together. Okay, so when I ask what's the probability summing to 8, I know the bottom number would be 36 because there are 36 possible outcomes. Now, how many ways do I sum to 8? How many outcomes are in that event sum to 8? I can see them right there, right? There are 6. Okay, so the probability here will be 6 over 36, or reduces to 1 out of 6. Okay. So that's one way to, and then you can now you can answer any question. You know, what's the probability of summing to 5, sum to 4? What's the probability of summing to 10? Well, there's no 10s on here, so that would be 0, right? But once you have the sample space and you have a list of all possible outcomes, questions about probability become a lot easier. The last thing that we'll do is let's now do a game where we have the red die versus the blue die. Okay, and they're going to play a game. Every time you roll the dice, the higher number wins. So in the long run, who's going to win more, red or blue? What do you think? Okay, well, again, we can make a list of all possible outcomes if we roll the red and the blue die by doing these tables, right? So on this table, it's going to be similar, right? Going to list this 0, 0, 3, 3, 6, 6, 1, 1, 1, 5, 5, 5. Okay, I make my little quick table here. But now I'm going to write who wins, right? And this will help me answer the question of who's going to win in the long run. So let's see, what was this? Let's see. The red is on top, right? So here, red would win. 1 beats 0, 1 beats 0, 1 beats 0, 5 beats 0. Red's going to win all those, and red's going to win all of those, right? But what happens if the blue rolls a 3? Oh, now blue wins against the 1, but loses against the 5. Wins against the 1, loses against the 5. And then now the 6s, blue's going to win every time. Blue's going to win every time. Okay, here's a list of now my sample space. And now I can do some counting to figure out who's going to win. So what's the probability that red wins? Right, again, we have 36 outcomes. How many R's do we have? I don't know. Okay, there's, let's see, 6, 12, 15, 18, right? red wins half the time, right? Okay, and then blue, what's the probability that blue wins? Well, it's the other half, right? So there's 18 as well. So this is a fair game, right? The red is in the long run going to win half of the time, and the blue is going to win half the time. So in this one, it doesn't matter which die you pick, it's equal, right? But some of the ones that you do, one will have the advantage over the other. So you're going to play around with those problems. So when you're trying to decide, okay, which die should you choose, the green or the yellow, it's helpful to make these tables to make your decision. Okay, I hope that helps with these assignments. And send questions my way if you have any. And I hope you have a good week, and I'll talk to you later. Thanks. Bye.